Hi, everybody. This is the final mini lecture for Physics 165 Climate Change. Today, I'm going to just spend a few minutes talking about an unusual topic, which is geoengineering, which is going to lead to some kind of final words that are kind of my opinion on where we're headed. So, before we get started, I wanted to mention a PowerPoint that I've put on OnCourse that you should check out. It's a slide presentation I've used in previous years that really doesn't work very well for an online setting. It's about bad arguments about climate change, and it discusses logical fallacies and unfair tactics that are used by climate change skeptics and also occasionally climate change believers in discussing the politics of this subject. So it's worth checking out. Anyway, my main topic for today is geoengineering. And by geoengineering, I mean the deliberate large-scale manipulation of an environmental process that affects Earth's climate in an attempt to counteract the effects of global warming. All right. So this is focused less on changing what we do and more on deliberately affecting the Earth itself in a way to deliberately change the way global warming is happening. So these kinds of geoengineering plans come in two basic strategies. As we've talked about with the Earth's energy balance at the very beginning, you've got sunlight coming in, you've got infrared trying to get out. Carbon geoengineering focuses on trying to remove carbon dioxide from the atmosphere. Examples of this are planting more forests, trying to fertilize the oceans to get them to take up more carbon, or technological machines that filter carbon dioxide from the atmosphere. The other side of geoengineering is solar geoengineering, which is not trying to modify the sun, of course. This is all about trying to change the Earth's albedo so that it reflects more sunlight. You can imagine making the Earth whiter, it would make it cooler. How do you do that? Well, you can't go around with a paint can, but you can use stratospheric aerosols to try to reflect sunlight away, or down in the lower troposphere, you can try to create more clouds. And the idea of a space umbrella or a parasol has even been floated, a large structure in space that would reflect sunlight away from the Earth. Here's a slide that talks about some of these methods. CO2 removal on the left, solar radiation management on the right. These ideas range from strategies that we've already discussed in the context of mitigating climate change, to completely space age ideas that are, in the distant future, if they're even possible. So we're definitely thinking potentially very far forward into the future, or maybe not. But that's kind of the focus here, is on technological methods to affect Earth's climate in a deliberate way. So I want to talk about a couple of these methods and emphasize the fact that these are not just science fiction. One example is thinking about ocean carbon uptake. The oceans are full of single-celled plants that are sucking up carbon dioxide. These get eaten by animals, and the poop from the animals falls to the seafloor, taking carbon out of the surface ocean and dumping it into the depths, and pulling it out of the atmosphere as a result. In many of these ecosystems, the limiting factor for plankton growth, for plant growth, is not availability of sunlight or water, but a particular fertilizer, namely iron. The more iron you have, the faster these plants can grow. And so the argument is, if you were to add iron to the ocean, even in tiny trace quantities, you could trigger a plankton bloom and suck up carbon dioxide from the atmosphere. This has been tried in a limited way in scientific experiments, which were quickly put to a stop because people weren't sure of the consequences and needed to decide where they were going to do it anyway. But despite that, occasionally people have been doing it, including individual entrepreneurs. So a US businessman about 10 years ago bought a ship, sailed it off the coast of Canada, Washington, Pacific area, and dumped a bunch of iron sulfate into the ocean. His rather clever business strategy was twofold. First, his plan was to get to sell the carbon credits for capturing a bunch of carbon dioxide. And his second plan was to sell the location of this plankton bloom to salmon fishermen so that they would know where to go to find a big catch. It's got him into all kinds of interesting trouble with the US and Canadian governments. The point, though, is that some of these, oh, and it didn't work very well. It triggered a plankton bloom. You can actually see it here. But it didn't appear to, oops. It didn't appear to suck up much carbon. As we've discussed before, when you grow plants, you get animals. Animals eat the plants, and they create CO2 by respiration, and the CO2 goes back into the atmosphere. So this strategy didn't work out all that well, except caused all kinds of really interesting legal and international legal issues. All right, but the point is, one guy did this. Another interesting technology is free air carbon capture, machines that suck up air and blow out air with less CO2 and then take the CO2 and do various things with it. I will say that these get a lot of hype in the news, but they are unbelievably expensive and do not appear to be viable in the near-term future, just from a cost standpoint. It's technologically possible, but hugely expensive. And it requires a huge amount of energy. And if your fossil fuel source for that, if your energy source is fossil fuels, then you end up just wasting your time. Maybe in the distant future, once we get our fossil fuel habit under control, these strategies might be useful for pulling the last bit of CO2 out of the atmosphere. But for now, all right. Let me turn my attention now to solar geoengineering and strategies for trying to increase the Earth's solar reflectivity. So there was a really interesting paper in 2009 that really sparked interest in this. And the strategy talked about, well, we've talked about aerosols in the past. We've talked about how volcanic eruptions can blow sulfuric acid droplets into the stratosphere, where they will linger and reflect sunlight and cool the planet significantly while those aerosols are in the atmosphere. So this guy, Robach, suggested a strategy of flying airplanes up into the stratosphere, deliberately burning sulfur-containing compounds to create sulfate aerosols up in there, deliberately creating pollution in the stratosphere. This pollution would reflect away sunlight and cool the Earth. Did some computer simulations and showed that it would totally work. All right. There's some really interesting highlights to this paper. All right. Overall, he found that this strategy would, cool the planet, potentially stop the melting of sea ice, slow sea level rise. Generally, it would combat global warming while it was happening. However, it comes with a bunch of very dangerous consequences. Probably not the least of which is the CO2 from fossil fuels would still be going into the atmosphere. We'd still be burning fossil fuels, and the greenhouse gases would still be there, but we would be dimming the sun effectively to try to combat the problem. These aerosols only last for a couple of years at the most. And so once we commit to doing this strategy, were we to ever stop, then all the global warming that we've saved up by this process, potentially for decades, would all come back in just a very short amount of time. So it could be one of those things where once you start, you have to keep going or you're in trouble. And we have a tiger by the tail situation. In addition, the simulations suggested it could cause depletion of the ozone layer. Regional droughts, of course, dimming the sun is bad for solar power. The skies would be less blue and more hazy. Problems with astronomy, and we've talked about ocean acidification, adding CO2 to the oceans, causing the destruction of ocean ecosystems. That would still happen under this scenario. And the ethical and moral issues are endless with this. The author himself said in a news article that he's got a list of 27 reasons that we really shouldn't do this. My quote by Al Gore got cut off, but he said this strategy was utterly mad and delusional in the extreme, and nobody should even remotely consider this. And it is, I think many of you are probably repulsed by the very thought of deliberately polluting the earth to try to combat our own pollution rather than cleaning up our act. All right, but I want to make one really important point, which is this paper also calculated the costs of doing this, and calculated you only need a little bit of sulfur to create kind of a lot of these aerosols. And the paper calculated that using existing US military aircraft, the annual costs of injecting enough aerosols into the stratosphere to completely stop global warming would be several $billions a year. That's billion, not trillion. That's a tiny amount of money. That's the amount of money the US could spend easily, no problem. All right. It's the kind of problem that even a smallish to middle-sized country could spend, right? Not even a superpower. And so if you find this idea repulsive, and many do, you should wonder, what if some other country just decides to start doing this? All right. What would we do about it? Go to war with them to stop them from saving the earth, sort of? Anyway, the moral and ethical issues here are remarkable, and the fact that the price tag is apparently temptingly cheap compared to the cost of actually deploying a green economy. That a lot of people are thinking about this very seriously as either an idea with real potential or an idea that we should be really worried about. It's not yet at the level where an individual billionaire could really afford to do this. But a small country could. And if they do, what should we do about it? All right, so moral and ethical issues aside, just a quick summary of kind of what the ideas are here. I mentioned afforestation, planting new trees. This uses a lot of land that we need for agriculture and other purposes. And as I've talked about in the past, it's really tough to keep the wood from rotting and returning its CO2 to the atmosphere. Ocean fertilization doesn't seem to work very well. Plankton just get eaten and returned as CO2 to the atmosphere. Same deal as on land. Technological carbon capture is really expensive and uses energy that currently would be provided by carbon dioxide, which just makes the problem worse. The stratospheric aerosol technique is probably cheap and probably would be effective at solving some of the problems of climate change, but it doesn't solve all of them. It causes massive side effects, and you have this problem where once you start, you can't stop. Cloud seeding of the lower atmosphere is expensive, poorly understood, and this idea of putting solar reflecting mirrors in space is deep future tech, and nobody has a plan for how you could build something so large. So, but this is just to give you a flavor of the kinds of ideas that are being thought of in terms of geoengineering, and it's up to you to decide what you think about these strategies. The point that I'm making, though, is that whether you like the idea of geoengineering and find it attractive, or you think it's utterly repugnant, this is sort of getting to my sort of closing point. The important point is that it's possible, all right? Shaping climate is something that humanity can do now. And the existence of the word geoengineering and the fact that we're even having these conversations reveals a really important truth about how humans relate to their planet. So for the first time in human history, we're not just passive witnesses to climate change as it's affecting us. We're in control of it now. We are in charge of the Earth's climate. Over the years, countless environmental problems have been caused by humans thinking the world was too big and humanity was too small for our actions to matter. What are little humans going to do against the size of the planet? But that's no longer the case. Through our population, through our technology, through our success on the planet, we are as big as the world is now. We have the power to create planet-sized problems like global warming, but we also have the ability to create planet-sized solutions, right? Our power comes with responsibility, but the fact is that we have the power to enact change. Whether you like it or not, we are all now geoengineers, and the Earth's climate is now our responsibility to design, and we are in charge of shaping what happens to the Earth. We can't step away from that power. It is by a virtue of just how many of us there are and how much technology we have and what we can do. The only question remaining for us as geoengineers is whether the design we choose for the shape of our planet in the future is one that will be thoughtful or careless, and what tools we're going to choose to use and which we're going to set aside as we shape our planet going forward. All right, thank you very much, and have a pleasant summer, I hope.